And then hand it over to you.
Yes. Yeah.
Hi, everyone. Welcome to another webinar from Data Driven Science. Great to have you guys here. I'm looking forward to talk more about machine learning algorithms today. Also, if you have any questions, please post them in the chat so we can answer those. We want to make it an interactive session, as interactive as possible. I'm Jan. I'm the founder of Data Driven Science, and I'm here today with Achinkya Kole and Prakash Chandra Chipa, who are also working with Data Driven Science. And our goal is to create educational content for anyone who's interested in learning more about data science and artificial intelligence. Without further ado, I'm gonna pass it to Achinkya now, who's gonna lead the session, and he will talk more about ML algorithms.
Okay. So hello everyone. That's our slide. We are going to focus on machine learning algorithm, but let's not be blindsided by a single topic. For machine learning, what we need to know is we need to know every single thing which is making our thing of ML. So there is a really nice website which talks about every single aspect of machine learning. This website is made with ML. Okay, so let me just bring that website here and let's see how that website has divided machine learning into individual components. So it starts, you have basics of notebook, Python, NumPy, Pandas, PyTorch. Then you have modeling. So here we have linear regression, logistic regression, neural network, and then some new topics like data quality and different utilities. In deep learning, we have convolution neural networks, embeddings, recurrent neural networks. Then attention and transformers are extremely popular. They will be added here by this person, Guku. And here is the rest of the project, which I really find incredible. So you see, machine learning is not just about machine learning. And even in machine learning, it's not just about algorithms. You have to think about the product. You have to think about data. Modeling is just one small part of the whole process. And even in that, we have stuff like experiment tracking. Let's say there are three people who are running experiments at the same time. Who is doing what? How do we know if we are making progress or not? All these things is a part of the problem. Same thing, scripting. You should know some bit of Linux, then application, then testing, version control and productionization like dashboard, Docker, CI/CD, and all of these fancy new words, which I'm sure you would have heard for the first time. This is what the entire machine learning is all about. So before we talk about algorithms, I want to make it very clear that algorithm is a small part of this whole ecosystem. Prakash, you want to add something on this? When you deployed few projects live, what was your this thing? Any extra sub part you think is in
This
machine
is
learning? Anything missing?
right. I mean, this is a really extraordinary introductions, and when I look at the things from a industrial professional perspective, also, I must say that most of the things here it is like pretty much covered. That machine learning is not about algorithms, but you're talking about the production environments, how to manage the code, how to work, being in the team, data analysis. I think it's pretty much well. Few things to be added, which is like. Which is about like how to conduct the brainstormings, how to make the idea, how to develop the R&D strategy for any project. That could be added as in a part, and beside that, everything looks great to me. And just maybe how to use the cloud computing platform. That could be
Right. Cloud
one of
computing,
the
and I would say data processing is missing here. Data processing is also a big part of doing AI. So I think those two parts are missing. Otherwise, everything is kind of like covered.
Yes.
And in terms, let's say you took a project and deployed to production, how much time did it take? So that we can give students a better idea.
It's a bit of tricky questions, and so I just assume that if we have finalized the algorithm already with respect to the performance, with respect to the throughput of the system. Then also it is a matter of like how it will be scalable, how it will serve the targeted audience. If it is a service based, if it is a cloud computing based services, you can understand the whole development deployment. It is a matter of maybe 12 months. Sometimes it is even beyond that, which I am not including the actual applied research part, doing identifying the methods and POCs. I'm not talking about that. I'm talking about ML development, not the ML applied research, which we typically do before making any decision about the methods, models, and everything.
Okay, perfect. So, as now we have this thing clear, which is machine learning is about everything else. These are still a beginner level slides, you could say. Advanced level stuff involves way more complicated data and extremely big volumes of data. And nowadays, if you simply go to academic torrents, you will find that there are insane number of data sets which are available. And the total number of value you could derive out of those data sets is quite a lot. In terms of this thing, how Netflix recommendation has proceeded, it is a very interesting blog. So it's like Netflix recommendation progress. If you just take a look at this, is I don't know whether it's the deep dive one. Recommendation of Netflix started from a simple thing, is improve the pre-existing recommendation. Then it was like segmentation. Then it was a better profile picture to recommend to users. All of these things are part of the recommendation system. So you see, this is how it looks like. The ones on the top are the highest likely to be recommended, ones at the bottom less likely to be recommended. This is what it means to be a business thing. Short-term events, continuous watching, context, blah 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 blah. So you see, this Netflix had a session on this in a conference, and they do talk about all evolution and how it has changed. So let's keep in mind that whenever we are focusing on the model, whenever we take any data set, the total number of things we could do from that data set is infinite. Okay, infinite things we can do. It's just that we take one problem and take it end to end, starting from doing data processing, then moving forward and actually getting towards the end of doing ML model.
Oh, it seems Sachinka is frozen. No, he's back.
Yeah, internet connection problem. So let's see forward and check a bit of slides now. Okay, so first thing is supervised learning. Let's understand what is supervised learning and what is unsupervised learning. First, when we talk about artificial intelligence, I still find many people confuse between AI, many people confuse between machine learning, many people confuse between deep learning. Artificial is nothing but way of learning. AI is nothing but way of learning from data. We can either do it using machine learning or deep learning. So how do we do AI? Either by using machine learning or deep learning. If the data is in tabular format, then we should be using machine learning. And if the data is unstructured data like images, videos, audios, then we should be using deep learning. So generally text, image, video, audio, all of these things are all part of deep learning. So I am currently using a software called as crisp.ai. This software is a deep learning system which is currently acting live to remove noise from my background. So if you check here, it is able to detect which sound is noise and which sound is specifically what I'm speaking. And how this system improves and how it removes echo and blah, blah, blah. These are all the things. This is a deep learning application. Whereas recommendation of Netflix, data is tabular. That is a machine learning application. So I hope difference between that is clear. Artificial intelligence, machine learning, and deep learning. If the data is tabular, ML is a better approach. If data is image, video, audio, text, deep learning is a better approach. Currently, deep learning is more popular. Everybody is focusing on deep learning. That does not mean that machine learning is become unneeded. I would say in industry, machine learning problem statements are way more than deep learning problem statements. Prakash works more in deep learning. So probably what are your thoughts on this ML versus deep learning? How frequent are ML problems and deep learning problems?
Yeah, see, the way you have explained that when we have unstructured data, audio, text, and images, then definitely this called neural networks, right? Everybody heard about it. It's like universal learning machine, and that has created in a way that it really understand the data. It works nicely. So that is the reason that adoption towards the deep learning is more in the industry. But I just wanted to make it very clear, when it comes to a more sophisticated definition of machine learning, either in research perspective or even in the industry, deep learning is nowhere considered different. I mean, a different part, as in it just as in a part of machine learning. So one should have knowledge of machine learning and all their algorithms. Still the most popular, I must say, most successful way to start work with the I mean, in the whole field. Yes, when deep learning is popular because today in the era of digital world, we have a lot of data in terms of text, lingual data, images, and audio. And neural networks works best if we give them lot of data. Secondly, we do not need to construct the features by our own way. That is what we do in machine learning problem. So those are can be the 2 points that deep learning is being pushed in the industry. But when it comes to the differentiation, there is no comparative study, but deep learning itself is nothing but in a machine learning only.
Yes, deep learning, let me just clarify what Prakash has said. Deep learning is another way of doing artificial intelligence, and deep learning is actually a subset of ML. So, strictly speaking, that is what it means. So, machine learning and deep learning are both types of ways of doing AI, and deep learning is subtype. But Prakash, what my question was is, let's say we have companies, a company like Netflix, for
Mhm.
example. Recommendation really is a really common problem, right? Similarly, if we are on Amazon or Flipkart or Walmart, everybody uses recommendation. Recommendation is a AI problem, but it's tabular data. So we it's not a deep learning problem, right? So if I go on, let's say, Instagram and there is image editing on Instagram, that is a deep learning problem. So
Yes.
what my question was, in industry when they're hiring students for jobs, what are the more problems which are being solved? Are there a lot of machine learning problems to be solved, or are there a lot of deep learning on unstructured problems to be solved? Because in terms of hype, the hype of deep learning is highest. So someone new might feel like there are no machine learning tabular data jobs out there. I should just be learning deep learning. So beginners
No.
ask me that, okay,
Okay.
I know that machine learning algorithms are there, but should I learn NLP or computer vision? Because all I hear in news is deep learning. So that is what my intention behind the question was.
Okay, I mean, thank you so much for the explanation. Now I got your point also. See, yeah, why we hear more about deep learning, computer vision, or NLP jobs? The reason is straight that most of the business domains, industrial aspects, like they have data in terms of either images and text. So we hear more, especially from the startups. We might hear a lot of idea which directly connects to such data types. Thus it goes for the deep learning, but it does not mean that there are nowhere jobs for the machine learning part. And I must clarify here that most established organization in the very field of computer science, they have huge investment in machine learning problems. And I just finally wanted to comment on the part about the recommendation system. So I have a very insightful information to share that recommendation is the problem which was initially being sold, even the deep learning was not there. It successfully works almost every industry today. All the digital market, e-commerce, what we are looking into, those are some way the product of the recommendations only. On the other side, when the very same problem was adopted by deep learning and attempted to solve by the deep learning, there are very proven track of even the survey and research that deep learning did not show up much in the recommendation, although we invested highly in the infrastructure, but the result are nowhere good than the classical machine learning. So it also gives them the motivation that problems like tabular data, structured data, recommendations around that, still we are best with the classical machine learning methods only. And it is not just my opinion, but it is the opinion from the research community across the world.
Thank you. So, guys, I think many of here we have students here, and student community generally tends to get carried away by what is most hyped. So, right now, if you want to learn AI, it's great because AI is definitely in demand. But let's not forget that machine learning algorithms are still needed, no matter how hyped deep learning is. Okay. So let's see a tiny. Oops, my slides didn't get refreshed. Just a second. Let's see a tiny bit stuff about algorithms. Okay, where is, okay, it has come now. So let's see tiny bit about algorithms. So let's not see about types of machine learning. So I said we have AI. Oops. I said we have AI, and then we have machine learning and deep learning. So this is AI, and then in machine learning and deep learning. The most common thing people hear is supervised learning and unsupervised learning. What I want to do is I want to talk about supervised learning and unsupervised learning with context to deep learning and machine learning. So in machine learning, we have two types of learning: supervised, and we also have another which is unsupervised. Then in deep learning as well, we have the same types. We have supervised learning and we have unsupervised learning. So you see, it doesn't matter whether we are doing machine learning or deep learning. Supervised means when we know what we are trying to predict, that's when supervised learning it gets called. Unsupervised learning is we are just given data and we are going to extract intelligence out of it. So whether it is machine learning or deep learning, it does not matter. Supervised and unsupervised learning, they are the same. So the reason I brought it up is this slide. When we say unsupervised learning or when we say supervised learning, people feel like we are just talking about machine learning. But no, we can do supervised learning in machine learning and deep learning. Similarly, when we talk about unsupervised learning, which we will see the slide deck, probably we won't have time to go through all the slide deck. But let's not skip some essential stuff. Let's go through everything deeply. So even in unsupervised learning, problems like clustering, anomaly detection, these problems we can either solve them by machine learning approach or deep learning approach. So this is one important clarification for everyone to understand. I'm checking chat. If there are any questions here, please let us know and we can, take those questions immediately. Anyways, let's go back to algorithm part and let me just clear this slide and let's see how should we study algorithms. First thing, we should understand the algorithm's behavior. This is the first thing we should know when we are trying to learn the algorithm. What do I mean by that? Okay, so let's go back to the slide deck and let's go to an extremely common problem, which is linear regression. Okay, so linear regression. Let's go for linear regression. So linear regression is one of the easiest ways of doing machine learning. What does it do? We have data points. Let's say we have X, value X on one axis. And let's say we have Why? When we are trying to predict Y from input X, so we know what we are trying to predict. It means it has become supervised learning. Now, let's say we are given X and Y, and we simply don't know what patterns are present in the data. Same data set, but we don't know what we are trying to predict. Then this same data would have become unsupervised problem. Okay, so I hope this thing is clear. Now let's move back into linear regression. So what is linear regression? We have been given X, we are trying to predict Y, and we want to find a line which is able to predict. We want to find a line which is able to predict the corresponding value of Y with least error. This is linear regression. Okay, now the word which gives it away is the word called as linear. Okay, when we say linear, we know that it's linear regression. Let's say had there been parabolic regression, probably the curve would have been parabola, and if the data is like parabola, we would have been able to predict the value of Y with pretty good accuracy. Okay, so this is the linear regression algorithm. If we want to check the code of linear regression, we can actually find out the complicated ways of how linear regression actually works. Okay, so if you want simplified understanding of how this algorithm works, you have napkin ML GitHub. Okay, so what napkin ML is? So, Rishabh is asking questions on real life applications. So Prakash will reply on chat. So let's just continue with this linear regression. Okay, so let's say we are trying to do machine learning and we want to do regression. So the source code of this is actually not in examples, it is in utils. When I go into utils, let's go into miscellaneous and wait, where has the source code gone? Napkin ML, linear regression. Yes, that's it. Just one line. We are using a function of Numpy, linear algebra function, and we are trying to find out a line where square root of distance from that line, their sum is 0. So you see, let's say this is the line. Then in this line, this is the point which we, and this distance points from this line is vertical. We calculate this is the squared error. This is the error. And with help of linear algebra, we are trying to find out which line causes the sum of the errors to be 0. Now, I know this thing is going to be quite complex for everyone to understand here. So let's go to a bit more detailed machine learning algorithm, which is for same linear regression. So let me find out regression here. And let me also find out something which uses NumPy so that it's easier to find out. Okay. So I'm opening NumPy and I'm opening NumPy linear regression algorithm as well. So Napkin ML was using NumPy, but ready-made functions. ML from scratch is implementing everything from scratch. Okay. So regression, let's check. It has weight, it has training, it has calculation of error. This is the linear regression part. There is something regularization. There is this fit thing. We have dot product. We have blah, 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 blah. Okay. So when, we have how many people? 33 people, 600 people had signed up for introduction to algorithm. Do you think this complexity is for everyone? I will say no. Okay, linear regression is one of the most popular algorithms used, but very few times people will actually implement stuff like this. Even if you are using library like NumPy, still it becomes quite complex. That is why we use libraries. So if I'm using linear regression using Scikit-Learn, so Scikit-Learn, and let's say I'm using Spark MLlib, linear regression. We can see how Linear regression is done in Scikit-Learn, and the code is extremely simple. It is like this. We import the corresponding library and we call the training function. In Spark MLlib, it is exactly the same way. So if I check the Python code, let's see. If I want to check, this is the logistic regression, this is the linear regression. This is the linear regression done in Spark, and this is how it looks. Let's see, the program is loading. So this is how Scikit-Learn does it, and this is how Spark MLlib does it. It is a simple library which we can use it. The code is going to look something like this. We import corresponding stuff, and we import the corresponding library, and we simply call train function. So we call model.train, which is like train on the corresponding data, and we are done. Difference between Scikit-Learn and this library called as Spark MLlib, that this library works on big data. This library works only on small data. The reason I jumped to this is, let's go back to the slide we were having. The first most important slide. Whenever we are learning algorithm, first we need to understand the algorithm, not necessarily implement it from scratch. Implementing an algorithm from scratch is the last thing we should be doing. Rather, we should know how to use the algorithm, and we should understand the algorithm's behavior. So for that purposes, we need to understand, where does this algorithm work well? Where does this algorithm does not work well? What are the bad choices of data here? What are the good choices of data here? These are all the investigations of behavior we need to do when we are trying to learn the algorithm. So again, going back to the person who has deployed such algorithms in production, Prakash. So in this sequential thing, 1, 2, 3, what do you think? Do you feel there is something missing here? We should make some changes. How should students who are learning, what should they focus on when they are they have begun their journey?
Okay, so when students are beginning with their journey, then for sure they won't consider the commercialization scenario, but the moreover the learning part. Then, like, my advice is that first step, understand the algorithm is important, but it has to be done with respect to different problem statements. I mean, just learning the algorithm is like, we know the tool, but we don't know when to use it, how to use it. And machine
Mhm.
learning is something, experimental science, and one can only understand and digest the capability of every machine learning method and algorithm only when it is being played with multiple problem statement carrying out different data. So first, from the learning perspective, I must say that yes, focusing on understanding the algorithm should be done with respect to the problem and data statement, and nothing to worry about implementing it from the scratch. And that is the reason there are whole lot of libraries and frameworks are available for you, in order to, once we do step 1 and 2 and we feel very confident about different problems, then there might be an idea to further gain the insight. We just implement one or two out of even 50 method is also okay. So that should be the way, I think.
Perfect. So there is a blog which we have just shared, rather we are sharing on the chat. So if you check it out, this tells you how to understand a machine learning algorithm. So we hope to impart this knowledge that before you start implementing algorithm from scratch, there are a lot of other things we need to understand. Okay, so if you gain nothing from this session, is gain this. We should first investigate behavior of an algorithm. So it tells the exact same thing. Kind of like you choose a few algorithms to study. Then you kind of like find what is the understanding of that algorithm, how does it work. Then you write your own interpretation of that algorithm just as a theory to understand it, and then investigate. You try it on different data, you see which one works when, how is the accuracy for a specific thing, and you try a lot of these things trying to gain more and more and understanding of this algorithm. Many other times this is it, this could be the last step, but if you still want to go more, only then go for implementing. So implementation of that algorithm should really be a last step, though it shouldn't be the first step one jumps into. Okay, now there is something on linear regression. Let's check this documentation and let's understand important things in this linear regression. You see, here these are the parameters of the algorithm. It is saying fit intercept or not. Should we do normalization of the data or not? And how many times is like jobs in parallelization. So this is not really important for a beginner. And other attributes like intercept, cost, coefficient, these are what are returned. So the thing which we have control on is normalization. Okay, normalization is about the data. And check what is the diff value here. Default is false. It means if unnormalized data is given for the algorithm for regression prediction, probably we will not get a good accuracy. Why? Because we forgot how the algorithm behaves in Scikit-Learn. If the default had been true, then we wouldn't have had to worry about actually normalizing the data ourselves. The reason the reason this thing is default false is like generally whenever we are passing data, the data shouldn't be magically converted into something without me knowing. So normalization is an extra operation. It shouldn't be done by default. That is why there is always a flag. So when the student or the developer knows what he's doing, that developer knows, oh, this linear algorithm, I need to enable, normalization for it. So then I will go and say normalize equal to true to enable the normalization. This is what it means, that investigating behavior of the algorithm. One of the more popular algorithms is not just a linear regression, it is SVM. So let's go to API of Scikit-Learn and let's just open SVM. SVM algorithm is still I am mastering, so just a second. Okay, so linear SVM, but linear regression. This is the algorithm which I will open. Compared to linear regression, check how many parameters do we have here. We have parameters like epsilon, we have tolerance for stopping criteria, we have C loss, we have then these things. So I'm actually not sure about these parameters like C and epsilon. So do you know these so that we can tell a bit about these parameters to students? Parameters of SVM, parameters like epsilon and C.
Uh, I am actually, it's been a long time for me as well.
Okay.
Definitely this intercept scaling. So and it might be useful that we can comment on the video. I mean the comment section
Okay,
explaining
we'll
about
comment it
those. Yeah,
afterwards then. Okay.
yeah. That would be good.
So the reason I brought it up is knowing these things, which parameters are there, how important they are. This is what it means for us to be masters in a certain algorithm. So if I open SVM, SVR algorithm, here we will find algorithms like parameters like kernel. We have stuff like degree. We have stuff like gamma. Gamma is a very important parameter, so is kernel. If I have non-linear data, then we should be choosing RBF kernel. This is what we call in SVM. RBF kernel is able to fit any kind of data. If my data is not linear, okay, but it is polynomial, it is a polynomial like data, then I need to choose polynomial kernel. Sigmoid might be useful in certain kinds of situation. We need to find out when sigmoid works better, when it does not work better. Gamma is a parameter which is a scaling parameter. It's used for every kernel computation. What is the impact of low gamma, high gamma, how much regularization should be. So C is about, how strict is our algorithm be. So imagine it's Harry Potter. Imagine we have Professor McGonagall at one end when we have Dumbledore at one end. Okay. McGonagall means high regularization. What is regularization? For every mistake, you will be given detention. And whereas low regularization means, okay, it's okay. Even if you are wrong, let's not punish you quite a lot. Maybe you will do something right. That will be the hope if we are not doing any regularization. So C is that parameter of regularization. We need to know this well, because if the kernel which I'm using is RBF, then regularization should be kind of like a bit more. These are all parameters. Okay, so we have students in the comment are helping us out, talking about parameters like epsilon and this thing. Great. So first is knowing these things is important. Knowing, understanding this is important. And then, and only then, comes the final implementation of the algorithm from scratch. Implementation is different from using the algorithm. Okay, so let's go back to the slides now. And then take a real life problem from Kaggle. So real life examples of data science, we can best find them on competitions. So we should know companies who have created the competition, and then we can start Googling quite a lot. Okay, so imagine we go here, and here we say buy rewards. And currently, let's see. So Jane Street Market prediction. This is a competition currently happening. 5 months to go. Real market data. So all companies which are working on finance, whether the company is which Jane Street, or whether it is company which is Two Sigma or any other company, all of them have a problem like this. Around 4,000 teams are participating. Data looks like this. 5.8 GBs worth of data. If I check in terms of features, I don't know how many columns are there here. So we have 303 columns, a lot of details here. And using this, we can do the predictions of when to buy and when to sell. This is an example of a real life problem where data science is used. Okay. Similarly, flight detection, defect detection, housing price detection, recommendation. This is the best place for us to find out real life applications of our ML. Okay. Now, going back to the slide, going back to the slides, let's take the problem of predicting price of the house. For housing price predictions, we actually have two problems. Boston house pricing. This is a really simple data set, and anybody can get a good enough accuracy to do predict prices of the data on Boston housing. It is only 47 KB. We have a different problem predicting price of the house on Zillow. Data here is approximately 500 MB. No, it's not 500 MB. It is 1.27 GB. 50 KB versus 1500 GB. That is the difference between volume of data. So when we talk about regression, today we only saw about regression, that we saw how to do this linear regression using Scikit-Learn or Spark MLlib to do this. And if you want to do this more, this problem of Zillow and also Boston housing price is a great problem to experiment with. Reason we are not going into the details is, like I said, implementing algorithm from scratch should be the last thing we think about. We should first use the algorithm as is and then investigate its behavior. Okay, so for Zillow, here are some of the code discussions point. We are creating a starter kit for you guys so that you can do this yourself. Check out some of the algorithms here. If you find out which is good, so let's, instead of hotness, let's check most voted codes. So people have done a lot of codes, exploration of data on Zillow, simply applying this XGBoost algorithm. So this guy is a grandmaster, and it's pretty cool that on Kaggle, whenever we see who you are is immediately visible. You see, when you start acting on Kaggle, who you are is immediately color coded. So you see, grandmaster is this orange colors, and that's why this is orange. Now, if it is somebody else, according to that, that color is given to the user. So you can just pick whichever algorithm you have. So all of these unranked get coded as purple. So this is a starting code, and in less than 100 lines, you can actually do machine learning with help of XGBoost on this Zillow data. So we will create a starter kit, and we will share this on the same comment on this YouTube video. But hopefully this whole approach of having a problem, using algorithms to investigate behavior on that specific problem, hopefully you guys understand how the algorithms are studied that way. And we'll create compiler resource. So in the slides, I had prepared slides for regression, linear regression, logistic regression, and random forest. We had SVM as well. So four algorithms we had created in terms of slides, but this thing is going to be a quite comprehensive video which we don't have time for. So let us just create a summary of these algorithms. And I would like to conclude by just talking about one paper. Do we need 100 classifiers? This is my favorite paper in machine learning. This paper is an example of 80-20 principle. So imagine we are learning machine learning as a beginner. If we know which kinds of algorithm are used most frequently in the industry, and we master only them, we have a very good edge over everybody else, right? If we know which algorithms are used the most, we have very high edge with everybody else. And this is what this algorithm does. So the algorithm investigated of, on 100 data sets, it tried to kind of like find which algorithm generally works the best. Okay. So let me go to the end. It tried to investigate on 100 data sets, sorry, on, whatever number of data sets it has. What is like 100 classifier, it tried on 179 data sets. This is what this thing was there. 117 classifiers were tried on 121 data sets. And their conclusion was three algorithms were always in top three. Okay. The algorithms which were SVM, then we have logistic regression, linear regression, and random forest. Four algorithm: linear regression, logistic regression, SVM, and random forest. These four algorithms are generally in always top 10 performing algorithms, no matter the problem statements. So these algorithms will take a priority for everyone to focus on, to understand how do they work, how to kind of like understand them deeply. We will have individual sessions on each algorithm. But for now, this is an overview of approach. We start with a problem, we apply, for the code, we start the concept, we take a data and we apply that algorithm. And that is how we understand behavior of that algorithm. So those four algorithms will go into detailed afterwards. Right now, I hope this overview of these algorithms helped you in your approach on how to learn. Prakash, you wanna add something here?
Yeah, I think you nicely covered almost all the things. And just one thing I wanted to add, that very interesting paper you shared here, and it's all about like almost all the problem statements. There are few methods which are always outperforming. So what does it convey to us is also that, and today's era of machine learning also, it has been shown, it has been proven that using prior knowledge or or using better feature engineering is actually the way to further outperform on the performance of the machine learning, rather than just keep trying the different machine learning methods. Because so that also gives a nice direction besides supervised learning algorithms and unsupervised learning algorithm. These days, one of the very much like popular field has become self-supervised machine learning. And that self-supervised machine learning, if in one line I had to describe, it's not talking about the methods. It's a all good. It only talking about how well you can use your prior knowledge, your experience in terms of feature engineering, in terms of transfer knowledge, that will make difference in the performance, not the machine learning method. So the paper you have explained, I think it is well supported in today's time with self-supervised methods also. So this is just I wanted to add that.
I wasn't aware about the self-supervised things,
Yeah.
but awesome. So
All
the
right.
reason this is
Yeah.
important, guys, is if you take a wrong path when you are starting, you will waste a lot of time and efforts in something which is not really required. Instead of getting carried away in some, what blogs say, oh, linear algebra and algorithm implementing from scratch is important. But if it is not really important, according to the people who work in the industry, then you are actually wasting your time. So I hope you try to listen and take feedback from those who are working in the industry, and we are trying to take that perspective in our lectures to be more helpful, so that in less amount of time you get more results. So that's what we had, and we'll now conclude.
Yeah. So thank you so much, Ajinkya and Prakash, for this very insightful session about machine learning algorithms. Also, thank all the participants. I hope you got some useful information. Of course, there's so much more about algorithms that you have to learn, and you can learn. An hour is not enough time to cover all this. But we shared a few resources in the chat. You can check them out. And also, we have a course, machine learning course that's published on Udemy. We also posted the link in the chat. There also we go deeper on the algorithms. We also introduce a framework that can be used for machine learning projects called the 7 Stages of Machine Learning. Please check it out if you're interested in learning more. There's one last question I'm seeing here right now. Is there a course available on Coursera I could learn from also? Of course. There are many courses, online courses available on Coursera, on Udemy, on Udacity. There are YouTube lectures, obviously. So ideally, for your learning journey, take in as much as possible, learn from different places, so that you get a broad perspective on machine learning and data science. Yes, we will do more of those webinars in the future. Follow us on social media, on YouTube, on Instagram, on LinkedIn, on Twitter, to get all the updates about any future webinars. And also, we post a lot of resources that will support your learning journey in data science. All right. Thanks, everyone, again. Have a wonderful weekend, and let's stay in touch. All right.
Bye,
Bye,
guys.
guys.
Bye.